All right, so if this is our given information, following the directions here, first thing we want to find based on the graph is we want to find the amplitude, the period, and the phase shift. Remember, phase shift, or really any shifts, the phase shift has to do with the horizontal shift idea. Vertical shifts are also things that we've been looking at so far. So spelling these out, the amplitude, basically to figure out the amplitude, I'm looking for my highest point that this graph is traveling to. So the highest point this graph is traveling to, we've got a couple of points here. Both of those are located where y is 2. Our amplitude is going to be 2. To find the period. Now when we're given an equation, or we're given a function rather that we got to sketch out and graph, and we have to find the period, what we do is we take 2 pi, we divide by k. But if you're given the graph itself and you've got to find the period, you've got to remember exactly what the period means. You guys remember what the period means? Like, how would you find it looking at the graph?
Would you subtract 20 or pi over 7 from 22 times 7?
Okay, there you go. You're looking at your endpoints. Take your endpoints, and actually if you work at the end and subtract to the beginning. So take 22 pi over 7, subtract pi over 7. In fact, we use this as a way to check our graphs when we were sketching them out to make sure that we lined up all our points on the x-axis correctly. If you subtract that, your period then becomes, well, it's 21 pi over 7, right? So it's 3 pi. There's the period for this graph. Phase shift, which is known as the horizontal shift. Yeah, question?
For the period, do you not have to do anything because you always multiply it by a fourth?
You don't have to do anything because you always multiply by a fourth.
When we're going the opposite way, before, you always told us after you found it, we'd multiply it by 1/4.
Yeah. You'd multiply by 1/4 if we had to come up with the graph ourselves.
Right.
Because that distance gives us what we need to add on to find all of those little x values on the x-axis when we're sketching it.
Okay, but you don't have to like go backwards by like dividing it by a fourth now?
No.
Okay.
All right, so where were we? We were on the phase shift or the horizontal shift. Horizontal shift, that just marks where the graph's going to begin for one period. This graph begins at pi over 7. And even though I didn't include it in the directions here, if we discuss the vertical shift, for the vertical shift, this graph is not moving up or down, right? It's pretty much cemented around the x-axis, so our vertical shift is just going to be 0. In fact, all the problems you guys have in your packet for your assignment, you should notice that none of these graphs are really moving up or down. The vertical shift should all be 0. So taking this given information, coming up now with an equation which represents the curve. Remember the general form for an equation of a cosine or a sine curve. We've got y equals, we had a value of c, that went with the vertical shift. We added on a times the cosine of k times the quantity of x minus b. So when we first derived cosine and sine curves, this was the general form that we discussed. As we're going through this assignment, if we're not going to have any vertical shifts, this c part of it we won't have to worry about. That's going to be 0 anyway. So what we have to fill in the a, the k, and the b. And the nice thing is if we've gone through, found amplitude, period, horizontal shift, vertical shift, we've pretty much got all the stuff we need to find those values a, k, and b. So filling in what we know, we've got y equals. The a value here would be 2. Cosine of, all right, k is going to be a tricky one. K is not the period. K is just something we use to find the period. So if our period is 3 pi, what you do to find k is you set that equal to 2 pi over k. right? Normally, if we're going to find the period of a graph given its equation, we would say 2 pi over k is that formula to find that. We know what the period is already, so set 3 pi equal to 2 pi over k and solve for k. To do that, 3 pi would be over 1. I could cross multiply. I'd have 3 pi k equal to 2 pi. Solving for k, I divide 3 pi over. Got some pi's now that cancel out, and k is going to be 2/3. So the trickiest part in coming up with these equations that represent these curves is usually finding that k part. It's very easy to confuse k with being the period. Okay, but k is not actually the period. We have to use the period to find k. So k is 2/3. If we go back now, fill that in. I think the rest of what we need here should fall into place because b goes with that horizontal shift idea. B would be pi over 7. So just plug in, and there is your equation, which represents the curve of this function. So if I'm looking at this as my, my given graph, I recognize it's a sine curve, but I also recognize that it's been flipped over. So I'm going to have to account for that when I come up with my equation for the sine graph. But just like we did on the last one, let's go through our little list of key ingredients, finding the amplitude first. Amplitude, remember, you're looking at your high points here. You're looking at the y value at those high points. What would that y value be? Okay, be 1/2 based on the way this graph is marked. Period. To find a period, if you're given the original equation, you take 2 pi over k. If you're given the graph, you take where the period ends, you subtract where the period would begin. So here it's pi over 3, that's the end, minus the negative pi over 3, that's where it starts. You've got those double negatives, right? Yeah. And basically we're adding this together to get 2 pi over 3. So period's 2 pi over 3. Moving on to phase shift, which is horizontal shift. This represents where the graph starts. Okay, this graph starts at negative pi over 3. And then vertical shift on these, just to be consistent. We're going to notice that at 0 it doesn't move up or down. So setting up your form now for the equation. It's a sine graph, so y equals c plus a sine of k times the quantity x minus b. Exact same form as the cosine, it's just now we're replacing cosine with sine. C we don't have to worry about because vertical shift is 0. But if we plug in what we know, starting with A goes with the amplitude, and the amplitude was 1/2. So I'm going to put a 1/2 in. However, this graph flipped over, right? Since it's upside down, I have to make that a negative. Anytime the graph is flipped over, that lead value that's attached to the function there, that has to be negative. It's negative 1/2 sine of k. This was the tricky part, right? You have to use the period to find k. So if the period is 2 pi over 3, that's going to be equal to the formula to find the period. Hopefully we don't have to go through any solving here to figure out what k is, because what is k? K is 3, right? If you had to, like the last one, you cross multiply and find out the same thing. So k is 3, multiply to the quantity x minus b. B was the horizontal shift of negative pi over 3. So we're subtracting negative pi over 3. We add it on. There is your equation that represents this curve.